Hey guys, how's it going? So today I'm going to go over a very interesting IMO question, also known as International Math Olympiad. So this International Math Olympiad, or IMO, is known for creating some of the hardest questions, and it's a competition designed for the strongest math students in the world. And there was one question that had caught my eye because it's the closest I've come to understanding it and its solution. And here was the question. Find the sum of the digits of the sum of the digits of the sum of the digits of 4444 to the power of 4444. Now, you might have seen this already been solved. It was solved by a YouTuber called Black Pen Red Pen and by another guy called Michael Penn. And I will link their videos in the description below, in the description box below. But I just wanted to compare their solutions as well as my slight adjustment of their solutions. So here is Black Pen's Red Pen's method. BPRP, Black Pen Red Pen, or BPRP solution. They use the same principles, such, but I'm assuming you guys have watched the videos on Black Pen, Red Pen, and Michael Penn. So I'm just gonna briefly summarize them. So basically, he first finds the bound. So one, find a bound, and then needs to calculate number of digits in 4444 to the power of 4444. And the way he did it was by taking the log, of this number. So log 4444 to the power of 4444, which equals 4444 log 4444. And we know that log 4444 is less than 4. So we can say it's less than 17776. This implies that this number in question has less than 17,776 digits. Okay. Now, it's pretty obvious and intuitive that if you were to replace every single number by 9, then you would get a maximum. Like a sort of digit sum, basically. So it's like, for example, the maximum digit sum of a 2-digit number would be 18, and that comes from the number 99. The maximum digit sum of a 3-digit number would be 27, and that comes from 999. So we can replace all the digits of 17776 with 9. So digit D of 4444 to the power of 4444 is less than 17776 times 9, which calculates to be 159,984. However, Black Pen, Red Pen said something that is true and is perfectly logical to understand, and that's if a number m is greater than a number n, this does not imply that the digit sum of m is greater than the digit sum of n. And this will be important later on. And then he said 159, so D of 4444 to the power of 4444 is less than d of, now he said, now you could replace all these digits, 1599884 by 9 to get a maximum, but he said that that won't be very effective, and that's true. So what he did instead was keep the first digit, but then made all the others 9. So 1999999. And that calculates to be 46. And then one more time, d of 4444 to the power of 4444 is less than the digit sum. Remember, replace the 6 with a 9, so 49, that equals 13, and that's bound. Now, the second way, the thing we need to do is establish congruency. And there's a really nice formula to this that that was found, and it's that a number is congruent. I'm going to write cong to d of n, the digit sum of the number, mod 9. And the example was that 125 is congruent to 8 mod 9. I'm going to write this to avoid confusion. Mod 9. Like 1 plus 2 plus 5 gives you 8, and then mod 9 is like, you say like mod 9, what you're dividing it by. So if you were to divide 125 by 9, you get a remainder of 8. So then 8 is out in front. Let me just give a few more examples to fully help you guys understand what congruency is. So 100, the number 100 is divisible by 5, right? Is cong to mod 5. This technically could be a 0 out in front, but like you don't need to write that in, because when you have a number that's 0 mod something, it means that number is divisible by that other number. And 144 is congruent to mod 16, because you don't get any remainder when you divide by 16. And lastly, another example would be 10 is congruent to 4 mod 6, because when you divide 10 by 6, you get 1 with a remainder of 4. Okay, so yeah, that part's good. Black pen, red pen first did this. So he divided 4444 by 7, and no, sorry, 9, and he got a remainder of 7. So then it's has remainder 7, which implies that 4444 is congruent to 7 mod 9. And then he kept building up his powers. I'm not going to write the whole thing here because that would take up the whole page. So then 4444 squared is congruent to 49 of mod 9, which is congruent because 49 divided by 9 has a remainder of 4, so it's congruent to 4 mod 9. And then he did this to 4444 to the power of 4. It's congruent to 7 mod 9. And then he kept doing it all the way to 4444 to the power of 4444, and then establishing it. So if you watch his, like I said, I'll link the video in the description below, but then that he eventually worked his way up and then said 4444 to the power of 4444 is congruent to 7 mod 9. And it's actually true. And this implies, because when a number is congruent to something mod 9, then the digit sum is also congruent to that number mod 9. So that also means d of 4444 to the power of 4444 is congruent to 7 mod 9. Well, we now know that this number, 444, the digit sum of the digit sum of the digit sum of this number is less than 13 and is congruent to 7 mod 9. And there's only one number that fits both these restrictions, and that is 7. Yeah, okay. So this is black pen, red pen's method. And it's actually fairly easy to understand as long as you have a good background with up until pre-calc 12. It actually doesn't even require calculus and needs basic elementary number theory concepts and such. I get the mod 9 is a little confusing. I haven't taken number theory, so I was a little confused about it. But then once I started experimenting with different things, like it started coming together to me. I will say this though, however, so like I really liked how black pen, red pen was able to find the bound of this. This was perfectly logical. And his establishing congruency was logical too. But if you take a look at the video, you can go watch that when you're done here, or pause this, go to that, and then come back here when you're done, or don't, whatever. But if you go watch this video, this part 2, took, I think it was like 11 minutes to finish. And I think it's good, but I found a slightly, it can get tiring though. And if you're not careful, you can easily mess up actually, because we have to remember the powers, and then like it's easy to mess up, but it's easy to understand at the same time. My approach was slightly different from him. The way I did it was something along the lines of this. I'm going to erase this since I'll assume you had enough time to read it. The way I did it, my approach, I said that 444, I worked from the base of 1 up to him, but I took a bit of a shortcut. 4444 is congruent to 16 mod 9 because 4 plus 4 plus 4 plus 4 gives you 16. And then 16, 1 plus 6 is 7. And then remember that digit sum mod 9 formula. So then that's also congruent to 7 mod 9. Okay. So you don't really have to divide. You could just directly add it up. And then I said 4444 squared is congruent to 4 mod 9 because, well, I explained it earlier. And 4444 to the power of 3, okay, that's equal to 4444 to the power of 2 times 4444. Then that's congruent to 4 times 7, that's 28 mod 9, which is congruent to 1 mod 9. And then 4444 to the power of 4 is congruent to 4444 to the power of 3 times 4444. So that's 7 times 1. That's 7 mod 9. 4444 to the power of 5 would be congruent to 4 mod 9. 4444 to the power of 6 would be congruent to 6 mod 9. And it would keep repeating 741, 741 until you reach your desired number. Okay. Now here's the thing though. You don't want to go from 1, 2, 3, 4 all the way to 4, 4, 4, 4. So this is what I did instead. Digits d of 4, 4, 4, 4. I'm considering the exponents here, not the number over 4, is equal to 16. And since we have three numbers, 7, 4, and 1, and there's a pattern, I'll call A1 7, A2 4, and A3 1. So I'm going to consider mod 3. And notice how every third factor is congruent. Every third factor is congruent to 1 mod 9. So like 4, 4, 4, 4 to the power of 3 is congruent to 1 mod 9. 4, 4, 4, 4 to the power of 6 is congruent to 1 mod 9. It's like if the exponent was a number divisible by 3, or the greatest common factor was 3, then was congruent to 1 mod 9. So the digit sum of 4, 4, 4, 4 is 16. And then 16 is congruent to 1 mod 3. In other words, 4, 4, 4, 4 divided by 3 leaves you with the remainder of 1. And this implies that, that 4, 4, 4, then 4, 4, 4, 3, like 4, 4, 4, 4 to the power of 4, 4, 4, 3. Remember I said any 4, 4, 4, 4 to the power of a number divisible by 3 gives you 1 mod 9. Then 4, 4, 4, 3 is congruent to 1 mod 9. So yeah, congruent to 1 mod 9. And then I took a bit of a shortcut and then said 4, 4, 4, 4 to the power of 4, 4, 4, 4 is equal to this times 4, 4, 4, 4. And then I got 7 mod 9. So it took me about 3 minutes to get it. Then 4, 4, 4, 4 to the power of 4, 4, 4, 4, Cong 7 mod 9. I'm running out of space here. Okay, so this is my approach and black pen, red pen's approach merged together. I'm going to get rid of all this, and now we're going to analyze Michael Penn's solution. I'm not sure if that's how you spell his name. This is the correct Canadian or American way of spelling it, but yeah, typically, but I know there's some exceptions. So Michael Penn, I had to understand black pen, red pen's solution before I was able to follow Michael Penn's. Like Michael Penn's is a lot more compact, but it's harder to follow. So, and in his video, when I post, he went over the congruency first before establishing the bound, but for the sake of making it equal to black pen, red pens, I'm gonna show you his way of finding the bound first before I show you how Michael Penn came up with how it's 4, 4, 4 to the power of 4, 4, 4 is congruent to 7 mod 9. Okay. So first, find a bound. He did it the other way around, but like, yeah. So he said that there's actually a formula, and it's like to find the number of digits of a number. It's like 1 plus log base 10 of that number. So then he did 1 plus 4, 4, 4, 4 log 4, 4, 4, 4. I don't really know why he put the 1 in front of this. This is similar to black, but I haven't taken number theory, and he seems credible as a professor, so I'll just trust that this is true. Okay, and equals 17777 or 1777. No, I'm just joking. And this implies that the digit sum of 4444 to the power of 4444 has no more than, is less than 1599993, because when you multiply this by 9, you get 15993. Okay. Now, and then he said that like he multiplied the number of digits, num of digits, which is 6. I'm gonna do the brackets here, and multiplied it by 9, which gives you 54. Now this is black pen, red pen said that this wouldn't give you an appropriate bound. Like I remember BPRP did it like d of I'm gonna write n for 4 to the power of 4 because I don't want to keep writing it. Is less than d of 1999999. What Michael Penn here is doing, MP, is d of n is less than d of 999999. So they just have disagreeing viewpoints on the bound, but it seems like so far it's logical. I could follow it. So this implies that d of n is less than 54, right? Okay, well, and then if you look here, he said that d of n is less than is less than d of 49, and that's 13. No, less than or equal to d of 49, which is equal to 13. Okay. Now the what should I call it? 49 has the greatest digit sum between 1 and 54. Like you have a small enough space that you can actually compare every single number. And why, you might ask, why didn't he do something like this, like d of n, and then why didn't he copy black pen, red pen, and then say it's less than or equal to the d of 59, and then said it's less than 14, or equal to 14? Well, that's because 54 is the absolute highest number that d of n can equal. And it doesn't make sense for the d of n to be higher than 54. Like the maximum is that. Now, both of these are relatively easy to follow. Yeah. Now, here's Michael Penn's second part, where he technically his first part, but find congruency. Was a little hard to follow. It went something like this. Let me see if I still remember it. I watched it, the proof this afternoon. Yeah, so he established that n is congruent to digit sum mod 9. And then he said that what did he say? What did he say? I'm trying to remember. Something about 7 mod 9 and 4 mod 6. Okay, yeah. He came up, I don't remember the exact notation of what he did, but it was like I think it was like phi of 9 because like we're interested in digit sum mod 9. And then he had all these like these curly spaces like 1, 2, 4, 5, 7, 8. And he was looking for the number of numbers between 1 and 9 that had a greatest common denominator of 1. Okay. And then he didn't include 3 and 6 because the greatest the common denominators with 9 and 3 and 6 are 3. So then there are 6 numbers between 1 and 9 where the greatest common denominator between 1 and 9 is 1. Okay. So then he divided 4 and then realized 4 is congruent to 4 mod 6. And 4 is congruent to 7 mod 9. I'm not exactly, I don't exactly remember how he got the is congruent to 7 mod 9, but like it's pretty obvious when you add 4 for all the digits, 4 plus 4 plus 4 plus 4, that's 16 mod 9, which is congruent to 7 mod 9, like I said earlier. So he said something like this, and then he did this power 7 to the power of, no, sorry, 4444 to the power of 4444 is congruent to 7 to the power of 4 mod 9. And then he was eventually able to prove that this is congruent to 7 mod 9. So this method that Michael Penn used is a lot more technical, but it's much faster and safer than black pen, red pen's method. Like this one, it requires a bit of memorization unless you're really good at proofs and have taken number theory. So which method do you use? They're both very good. That's my final verdict. Like if you struggle to understand this, black pen, red pen's method of finding congruency is viable. Just be very, 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 very careful about it. Or you could use my method. I don't bash on black pen, red pen. I think it's faster and is 4 times faster than that, where you find 4444 to the power of 4444. Oh, sorry, I'll write it down in case. Like 4444 to the power of 4444 is equal to 4444 to the power of 4443 multiplied by 4444. And then is congruent to 1 times 7 mod 9 congruent to 7 mod 9. So like I personally prefer my method, like with the congruency combined with black pen, red pen's method. Michael Penn's method is also logical and very nice, but to understand it, I highly recommend you watch black pen, red pen's method of solving this IMO question before viewing Michael Penn's video that's 3 times shorter. That's 3 times shorter, and also 3 times shorter, and like also view it multiple times to fully understand it. So I'd love to stay now, but I'm way past time. I'm a little tired right now. This has been a very interesting problem. I've never really participated in IMO either, so it's nice to see one of these problems in action. I'd love to, for now, I gotta jump. I'll see you guys on the other side of the bridge. Catch you next time.